Okay, here we are working with the third example of our applications of systems of equations. We have a right triangle, which means it has a right angle, and it has a perimeter of 3 meters. Its hypotenuse is 130 centimeters. So our hypotenuse is always the side, well, that's interesting. It's always the side across from our 90-degree angle. So I've labeled my hypotenuse as 130 centimeters. What are the lengths of the other sides? So I've labeled my other two sides, the A and the B. So I'm letting A and B represent the lengths of the two unknown sides of the triangle. I'm going to use P to represent the perimeter of the triangle. So that means if we know the triangle has a perimeter of 3 meters, 3 meters is the same thing as 300 centimeters. So 3 meters is equal to 300 centimeters. I know that the perimeter is 300 centimeters. Perimeter would just be A plus the B plus the 130 centimeters here. So we have the fact that 300 was our perimeter. So I'm going to put my 300 there. So where we have P, I'm replacing it with 300 because that is our perimeter. And we have 300 equals A plus B plus 130. Now, I can solve that equation for either an A or B fairly easily there. Now, the other thing in here, so I've kind of used this first sentence, I have the hypotenuse already labeled. I don't really have another statement where a second equation falls out very easily. But I do have some knowledge from previous years. I know this thing called the Pythagorean theorem. And the Pythagorean theorem says that the length of the hypotenuse squared is equal to the sum of the squares of the lengths of the other two sides. So our Pythagorean theorem could be something that we already know using our knowledge base and can apply in this case. So our A squared plus B squared will have to equal 130 squared, the hypotenuse squared. So Pythagorean theorem. So there's my equation 2. Okay, I've got equation 2 or 1, depends, it doesn't matter which one's which. I'm going to solve equation 1 for A or B and then sub it into my equation 2. So if you want to give that a try and then check your answer, that'd probably be a great idea. Okay, when I solved this quadratic equation, I ended up with a common factor of 2 and two numbers that would add to negative 170 and multiply to 600 were these two numbers here. And because it's a simple trinomial, I could just plop them into my brackets. That gave me my two values for B. Now all that this is saying is that I could rotate that triangle. They're both positive values, so they're both perfectly fine to be for in there for the B. And when you sub that into my other equation, I got my A value being 50 or my A value being 120. So really, your two side lengths are either 50 and 120 or 120 and 50, which really is the same thing, just a rotated triangle. All right, so therefore the two unknown sides of the right triangle are 50 centimeters and 120 centimeters. All right, determine the value of k that will result in the intersection of the line y equals 2x plus k with the quadratic y equals x squared minus 4x plus 8 at 1 point and at 2 points. All right, so if you want to think about that one, this one's not as difficult in terms of you don't have to worry about your modeling or your setting up, but really what we want to do is have my two equations, so equation 1 and equation 2. The line can be equation 1 and the parabola can be equation number 2. We want that to intersect at 1 point. Well, let's see if we can solve for a point of intersection here. Now it's going to be in terms of k, but that's okay. Try and do a substitution there, sub 1 into 2 or 2 into 1, and see what happens. Okay, so I'm going to sub equation 1 into 2. And we're going to have 2kx plus k equaling x squared minus 4x plus 8. Okay, I'm going to get everything to one side. I want my x squared to be positive, so I'm going to put 0 on the left side. Keep that as a positive x squared. I have a 2x on the left. It's going to be a subtract 2x to undo it, so that'll be a subtract 6x when I put it with the minus 4x. I still have my plus 8 here, and I'm going to undo the plus k by subtracting k. Now, in this quadratic, we want it to have one point of intersection or one solution. Now, because I don't know how to factor, or I don't know, I mean, I would be adding to -6, but I'm multiplying to this wonky 8 plus 8 minus k. And like, what is that? I'm not exactly sure. But what I do know is if I work with the quadratic formula, I know that x would equal negative b plus or minus the square root of b squared minus 4ac. I just can't help but break into song when I sing this one, all divided by 2a. Okay, so think of that dancing baby and what it has done to your brain. In terms of this, I want there to be one point or one value of x that's true. So when we've talked about this in previous math courses, we talked about the fact that you get two solutions when this thing under the square root sign ends up being a positive, because you have your negative b, and then you're going to add the answer you get when you square root that part under the square root sign, or you would subtract that amount, and that's what's giving us the two answers there. To get just one answer, we want to eliminate that b squared minus 4ac. We want that b squared minus 4ac to equal 0 for one solution, for one answer, or one point of intersection. Point of intersection. So that's what the POI is standing for, point of intersection. So if I look at my quadratic equation here, my a value is 1, so a equals 1. The b is that -6. The c is that whole expression of 8 minus k. So I'm going to sub that into this b squared minus 4ac, set it equal to 0, and then determine my value of k from there. So my b value is -6, so we're going to get negative b squared, so -6 all squared, minus 4 times 1 times c, which is 8 minus k. That has to equal 0. So simplifying that, we've got 36 when I square -6. I'm going to have a -4, which then is going to hop through this bracket of 8 minus k. So 36 minus 32 plus 4k equals 0. So I just bounced that -4 through that bracket. 36 minus 32 is a 4. So 4 plus 4k would have to equal 0. I'm going to subtract 4 from both sides. 4k equals -4. Divide both sides by +4. You get k equals -1. So the value of k that will result in that line in intersecting the parabola at only one point would be if k equals -1. Now, the question, so I can summarize that, but my next question is, what has to be true about k to have 2 points of intersection here? All right, so let's look at that. I know for 2 points of intersection, my b squared, so this is part b here, b squared minus 4ac has to be positive. It has to be greater than 0 for 2 points of intersection. So for 2 POIs, point of intersections. So if we put in our values here, we know that this -6 all squared minus 4 times the 1 times the 8 minus k has to be greater than 0. So we get 36 minus 4 times 8 minus k has to be greater than 0. So it's really the same equation, only it's not an equation anymore. It's what we call an inequality. And the rules for solving inequalities are the same as the rules for solving equations, except with one little modification. Anytime that you multiply both sides of the equation by a negative, or if you divide both sides of an equation by a negative, the inequality will flip. So when I subtract 4 from both sides here, it's not going to change that inequality sign. It's still going to be a greater than. So divide both sides by 4, we're going to get k has to be bigger than -1. So as long as my k is greater than -1, I'm going to end up with 2 points of intersections. If it's equal to -1, I get 1 point of intersection. The other option is if k is less than -1, that must be our third option, which means the line would never intersect the parabola. All right, so this thing underneath the square root sign, this is called the discriminant. So the discriminant, is that thing that distinguishes or discriminates between how many different kinds of answers that you are going to get, whether you're going to get one solution, two solutions, or no solutions. Equals 0 for 1 point of intersection or one solution, greater than 0 for two solutions or 2 points of intersections, negative or less than 0 for no points of intersection. That is something you should know from 3M or 3U math. Okay, so hopefully you'll remember that. You might want to add that little note about discriminant to your note to remind yourself to look that over as something that you should know, but you may have forgotten.